Hello everybody, I hope everybody is doing fine. So this is me and I welcome you today in this class, and in this particular class we will be studying light, which is chapter of class 10th. Okay, and in this particular lecture we will be studying its subtopic, and that is reflection of light. Reflection of light. So what we are going to study? We are going to study about reflection of light. Okay, so before starting, let's go to the next slide and let's try to understand some very important information about light. So in your higher classes, you will be studying that what is photoelectric effect. Photoelectric effect. You might have heard this effect, photoelectric effect. Where it is used to convert light into the electricity. Now what is photoelectric effect? We don't need to go deeper, like how it is used and what is how does it work. Okay, we will be studying all these things in our higher classes. For now on, we just need to know that what is photoelectric effect. So if you are asked, then you will say that photoelectric effect is the effect which is used to convert light into the electricity. I hope you got my point. Now let's try to understand what is light. Let's try to understand what is light. So light is an electromagnetic wave. Light is an electromagnetic wave. Let me write it here for you. Electromagnetic wave, which is responsible for our vision. So this is responsible for our vision. Okay, so what is electromagnetic mean? So electromagnetic wave means which has both the components. So if the wave has both components, which type of component I'm talking about? I'm talking about electric field and magnetic field. Electric field and magnetic field. So these are the components. If both components are found in a wave, then those waves are called as electromagnetic wave. So light is also electromagnetic wave, and it is responsible for our vision. Why are we able to see things around us? Because of light. If light is not present, then we will not be able to see things around us. Okay, I hope guys you got my point. Now let's move on to the next slide. Let's try to understand what is there. So here we will be discussing luminous and non-luminous sources. Okay, what we will be discussing? We will be discussing luminous and non-luminous sources. So luminous sources are the sources which has their own light, If I talk about the example of luminous sources, then the best example of luminous source is sun, okay, or candle, or better to say burning candle, burning of a candle. Now if I talk about the non-luminous sources, then these sources are just opposite of luminous sources. Luminous sources has their own light, but on the other hand non-luminous sources does not have their own light, does not have their own light. If I talk about examples of non-luminous sources, then moon is a great example of non-luminous source. Our earth is also a very good example of non-luminous sources. Okay, I hope my point got clear. Now if I ask you a question, that what is the main source of light, what is the main source of light, then what would be your answer? Okay, so let me tell you what is the main source of light. So the main source of light is sun. Main source of light is sun. Most of the light we get on the earth comes from the sun. Okay, so these are also very important things. Before moving ahead in this chapter, we need to have knowledge these things whatever I have told you. Okay, now let's move on to the next slide, and here we will be studying reflection of light. What we will be discussing here, we will be studying about the reflection of light. So to know about the reflection of light, let's take an example. We must play this game where we throw a ball towards the wall. In this image, you can clearly see here a boy is throwing a ball towards the wall. And after hitting the surface of this wall, the ball bounces back. Okay, the ball is bounced back. So the same thing happens with light also. Whenever a light falls on a surface, in this picture you can see a light is falling on a surface and it is bouncing back in the same direction, in the same medium where it was coming from, then this phenomena is known as reflection of light. Reflection of light. So the bouncing back of light is reflection of light. Okay, now let's suppose this is a glass. This is a glass, or this is our medium second, and this is air. This is air, or we can say this is our medium first. Medium first. So if a light is coming like this, it is coming like this, and after the reflection, it is going in this way. Okay, so what you have observed here, you have observed that light is coming from medium first and going back to the same medium. Okay, after the reflection, the medium is also the previous medium. So it means the medium is not changing here. So in reflection, what happens, if a light is coming from medium first, then after the reflection, it also goes back to the same medium. I hope you got it. Now let's move to the next slide. So here we will discuss some terms, some very important terms related to the reflection of light. So let me draw a diagram for your simplicity. So this is a light ray coming from this side, going back in this direction. Okay, this is our light ray, and this is light ray after the reflection. This is our surface. Okay, and let's try to understand some important terms which has written here. So first thing is incident ray. So what is our incident ray? This ray which is falling on this surface, or which is incidizing on this surface, is known as incident ray. Let me write it for you. Incident ray. And after the reflection, the ray which is going back to the same medium is known as reflected ray. Reflected ray. So this ray is known as reflected ray. Now what is normal? It is very important. To solve the numericals, we need to have clear knowledge about these terms. Otherwise, we won't be able to solve the numericals which will be coming on the later lectures. So what is normal? Normal is a line which is perpendicular to the surface. So this is our normal. Okay, I think you might have already know that what is perpendicular. Perpendicular is a line which makes the angle of 90° from the surface. So this is making the angle of 90°. So normal is a line which is just at the angle of 90° from the surface. Now if I talk about the angle of incidence, then it is very simple. What is angle of incidence? The angle made by the incident ray and the normal is known as the angle of incidence. So this is the angle of incidence. Angle of incidence. Now let me tell you here one other point also, and that is angle of reflection. What is that? Angle of reflection. So what is angle of reflection? The angle made by the reflected ray and the normal ray is known as angle of reflection. Like in this case, this is the angle of reflection. Let me write it for you here. Angle of reflection. Okay, so there are two angles we have discussed yet, angle of reflection and the angle of incidence. So this is our angle of incidence and this is our angle of reflection. I hope these points might have got cleared. Now let's move to the next slide. Angle of reflection I already told you. Now let me tell you what is object. So object is nothing. For an example, let me give you a basic example. Let's suppose that you are sitting or you are standing in front of a mirror. So this is your mirror. This is you standing in front of a mirror. Okay, and this is your image. Here your image is appeared. So for this image you are acting as an object. So you are an object for this image. Okay, you are an object for this image, and this is your image, this is your image, this is, and you are acting as an object. So I hope object, difference between the object and the image is clear to you. Now let's move to the next slide. So here we will be discussing the types of images. There are two types of images. First one is virtual image and the second one is real image. So to understand this, let me give you a very basic example which we have taken in the previous slide. What happens that, for an example, you are again standing in front of a mirror and this is your image. So can you touch your image going back to the mirror? Can you go back to the mirror and can you touch your image? No, you can't do that. Okay, because what happens in this case, in the case of plane mirror, the image is a virtual image. Okay, the image is a virtual image, so you can't touch it, or you cannot obtain it on the screen. The image that cannot be obtained on a screen is known as virtual images. So this image cannot be obtained on a screen, that's why it is known as virtual image. Now what is real image? Real images are just opposite of virtual image. In virtual image we cannot obtain it on a screen, but real images can be obtained on a screen, or it can be formed directly on the screen. So this is the basic difference between the virtual image and the real image. Okay, and if I give you an example of real image, then projector is a very good example. Okay, where we see a movie, so there the images are real because it can be obtained on screen. But in case of a plane mirror, if I give you example of virtual image, then plane mirror is a very good example of virtual image. Let me write it here for you. Plane mirror, it is an example of virtual image. Okay, now let's move ahead to the next slide. So in this slide we will be studying about the properties of image formed by a plane mirror. Okay, so again let's draw that diagram. This is your plane mirror, this is you standing in front of a mirror, this is your image. Now this image is virtual, as I already told you in the previous slide how it is virtual. Now what does it mean erect? Erect are the images which are just upright like this. For an example, whenever you see yourself in the image, then let's suppose this is you, this is point A, this is point B. So in your image also you can see this, the point A is here and the point B is here. It will not be like this, like point A goes A or point B goes here. Okay, this will not be the case in the plane mirror. If this happens, then these images is called inverted images. Inverted images. But in this case, in the case of plane mirror, the images are always erect. So if you are asked what is erect image, so you say that the upright images are known as erect image. But if the image is inverted, then those images are inverted images. Now let's talk about the size of the object. Let's talk about the size of the object. So what happens? One example, the height of the object is h in this case. So here the image size will also be h. It means the image will be formed same size as of the object. So image size and the object size will also be the same. Now let's move to the next slide. And before going to the next slide, let me explain this diagram. So in this diagram, the image formation is shown. Okay, image formation is illustrated. What happens in this case? In this case, actually this is a spherical mirror. Okay, I will be telling you later in this chapter that what are spherical mirrors. Okay, if I tell you here, then you will get confused. So that's why you don't need to take stress what are spherical mirrors. We will be teaching you it later, but for now on, just understand that these two mirrors are spherical mirrors. This is concave mirror and this is convex mirror. Okay, I will be telling you, I will be explaining these two terms very deeply in the later parts of this lecture. So here what is happening, you can see that a ray is going in this direction. Okay, a ray is coming from in this direction, and after the reflection it's going back like this. Okay, and this is other ray which is coming from this direction. After the reflection it is going like this, and these two rays is meeting at this point F. So these rays are actually meeting. So where rays are actually meeting, the real images are formed. So here in this case, the image forms is real image. But if I talk about this case, okay, if I talk about this case, so here rays are not actually meeting. They are appearing to be meeting at this point. They are not actually meeting, because if you move this ray here, and if you move it this ray here, then they will not be appearing to be meeting at any point, because they are in different direction. It is going like this, it is going like this, so they will not going to meet. But if I increase it behind the mirror, then they will definitely meet at this point. And here where they are appearing to be meeting, this point we can say that here the image is formed. And in this case, because rays are not actually meeting, that's why this is a virtual image. This is a virtual image. Okay, I hope you got my point. Now let's move to the next slide. So we were discussing about the properties of image formed by a plane mirror. So again, let me draw a mirror for you. Let's suppose this is you standing here. This is your image. So the distance of the object from the image, let's suppose it is h. Then the distance from the image of the plane mirror, the distance of the image from the plane mirror will also be the h. It means they are at same distance, at the same distance from the mirror as the object is in front of it. Okay, now laterally inverted, what does it mean? It is very simple. Lateral inversion is very simple. You might have observed it that whenever we stand in front of a mirror, what happens? Our right appears to be left. Okay, our right always appears to be left, and our left always appear to be right. So this is known as laterally inverted. Okay guys, so now on the next slide we will be talking about some laws of reflection. It is very important. In this slide, what we will be discussing, we will be discussing about reflection, laws of reflection of light. So if you have a clear understanding of these terms which we have discussed in the previous slide, then these laws will become very easier, very simple for you. This is incident ray, this is angle of reflection, this is reflected ray. Okay, then this is a plane mirror. So what happens? Our first law says that the angle of incidence is equal to the angle of reflection. Always, this rule will be followed always by our light. What happens whenever reflection takes place? What will happen? That the angle of incidence, what is angle of incidence? Angle made by the normal and the incident ray. So the angle of incidence will always be equal to the angle of reflection. Okay, now let's move on to the next slide. Now let's talk about two remaining laws of reflection. So second law says that the incident ray, the reflected ray and the normal to the mirror at the point of incidence all lie in the same plane. So for an example, this is incident ray, this is reflected ray, this is your normal, then these three lines will always be in the same plane. This will not be in the different plane. Now let's talk about third point, and that is the incident ray and the reflected ray lie on the either side of the normal. It simply means that this will not be at the same side of normal. Like for an example, this is your plane mirror, this is your incident ray, this is your normal. So if this reflected ray comes at this side, this will not definitely happen. This is not going to happen because reflection of light, laws of reflection of light will always be followed. So what will happen, this incident ray and this reflected ray will always be on the either side. Okay, so I hope you might have known about these three rules. Okay, so now I am ending this lecture, or in the later parts we will be discussing some later concept about the reflection of light. So here I am ending this lecture and see you later. Bye bye.